Hi, everyone. Thanks for joining. My name is Phil Derringer. I'm the VP of Product Management at Kinetica. And today we'll be talking about how you can extend Tableau to visualize massive geospatial data sets. We're going to show you a demo. But while we wait a few seconds for people to start, let me just tell you a little bit about myself. I've been in the enterprise space for over 20 years, working at a variety of different large and small startup companies like Oracle, Here Technologies, and real focus on spatial analytics and big data. Currently, I'm at Kinetica, where I lead the product management team. Kinetica is a real-time database with a focus on time series and spatial data. And today we're going to show you how you can use the power of Kinetica to enhance the analytics you're already doing in Tableau. All right, with that, let's switch over to the presentation. So just a couple slides to introduce the subject before we jump into the demo. So many of you are probably already analyzing spatial data within Tableau. Tableau provides a great set of analytic capabilities along with some geospatial visualization capabilities. So you can do things like look at the market penetration by city across the continental United States. Tableau's approach is based on client-side rendering, where the spatial data set is rendered in the client, in Tableau on your desktop itself. And that introduces some constraints around the size of the data that you can work with in Tableau. If you worked with this before, you probably know that above about tens of thousands or hundreds of thousands of points, you're starting to feel the limitations of this approach. The amount of data that you can work with, or the time for those queries to bring that data set back to your client and render it locally on your desktop. So a common approach then would be to downsample that large data set. Let's just look at a specific geographic area, or we'll compress or reduce the data set to a specific set of window of time and only look at a day's worth of data or a month's worth of data. But as we'll show in the demo, those downsampling techniques often would lead to missing potentially patterns in the data that you would see, or you'd be able to see, if you could look at all the data across the entire globe or across larger time ranges. So with that, we're going to show you how you can extend all the standard stuff you're doing in Tableau, all the analytics you're already doing, but enhance that with the ability to also analyze massive geospatial data sets. So let's talk about the data set that we're going to look at today. This is called AIS data, or Automatic Identification System. This is a system used in the maritime world so that all vessels are constantly reporting their location. They're reporting their location to other ships. They're reporting the location to shore, and in other scenarios over satellite. And what that allows is that other ships know where other ships are, or where reference points on the shore might be, so that they can better navigate and avoid potential accidents at sea. You may have heard about this data set, or people using this data set and analyzing this recently. A lot of recent applications, especially during COVID, for instance, looking at supply chain and traffic patterns. As we had some of these transitions around supply chain during the COVID era, looking at where boats were, large cargo ships were hanging out outside of ports, trying to understand where those bottlenecks were and if there were ways that we could reduce those bottlenecks to unblock the supply chain. Also scenarios looking at potentially dwelling ships that are staying in an area, maybe for suspicious activity. And also in the military world or in surveillance world, there were definitely been cases of AIS position spoofing, where they demonstrated how you could inject AIS data, fraudulent AIS data, into the system to make it look like ships were going where they weren't, or that ghost ships were transitioning through certain parts of the sea. So this data set specifically we're going to be working with is actually, for Kinetica's perspective, relatively small. It consists of 430 million messages from ships around the world over about a 2-week time frame back in April. With Kinetica, we're typically visualizing data sets much larger than this, in the billions of data points, but hopefully this gives you a good indication of how you can use Kinetica and Tableau for these types of data sets. All right, with that brief introduction, we're going to transition over to the demo. Okay. So what you see here is just a standard Tableau dashboard that I've set up to analyze this type of data. And for now, just we'll highlight some of the sheets that I've dragged onto this dashboard for the purposes of my analysis. I might want to look at things like the average draft or how deep the ship is for the different types of ships on aggregate that I'm going to be analyzing as I pan and zoom around this world. I want to look at their speed or their length. I look at the ship type. And again, this is all data that's encoded in those AIS messages. You can see a variety of different types of ships that are underway, whether they're cargo ships.
Hi, Phil.
Yes.
It's Deepika. I'm so sorry. Actually, there's a repetition in your voice. So maybe we could try putting headphones or do something about it.
I'm sorry about that. Let me just switch on to the headphones. Okay, is this better?
I think so.
This for now?
Let's try.
Okay, but don't need to repeat. You heard where I left off.
Yeah, please go ahead. Please go on.
Okay, sorry about that. So yes, just going on. So some of the different ship types, for instance, you can see there are cargo ships underway, fishing ships. You can see here military and rescue ships as well. You can also analyze the different flags that these ships are flying, representing the different countries where they're registered. The messages that they're specifically sending out, again, the vast majority of these are simple position messages indicating to other ships or to land where they are, and some indication of their status. Most of them are just underway using their engine, but you also see that certain ships are moored or are in port. Finally, we can look at binning of the speed of the ship to see what rate of speed they're traveling. And again, as I mentioned, the draft or how deep the ship is indicating how deep the water would need to be for them to be able to pass through. Okay, so far, all this is just standard analytics, no spatial component yet. But what I've also dragged into this dashboard is a specific Kinetica extension for Tableau. This is available through the standard extension gallery that you see here in Tableau. So if I click here, you can easily add extensions to your dashboard. I've chosen this Kinetica Geospatial Analytics extension for this specific widget. And now we'll just show you some of the brief configuration of that. Excuse me one sec here. Click on the data. We can configure this extension to point to Tableau. It's relatively straightforward. You just provide the URL or the endpoint of the specific Kinetica database that you're talking to, your credentials, and the specific Mapbox base map credentials you want to use for the base map that you'll be using here. Okay, but now I would actually turn on some visualizations is using this extension. And we support a variety of different extensions. We're going to start a variety of different visualizations. We're going to start with the most simple, which is just a feature-based geospatial visualization. So I want to take the feature, in this case, it's the position of those messages indicating where those ships are located. I'm going to render that as a feature. And I'm going to choose the color that I want to use and the size of the points that I want to use for this visualization as part of this specific layer in this extension. Right now it's disabled. It's not visible, but I'm going to turn it on. And that'll trigger a request. I'm sorry, I turned on the wrong one. Let's turn on the right one, feature. So this is calling our Kinetica backend, asking for a visualization of all those points on and projecting that onto the map. You can see here we're visualizing currently over 200 million points. And again, just rendering each one of those as individual points on this map. It's already interesting. You can see some of the major paths and routes that shipping vessels are taking around the world. And some of the patterns, you can see how it hugs the coast of South America, for instance. You can see the outlines of the continents. But otherwise, somewhat limited in terms of what other patterns or details you might be able to make out with this specific visualization. Also, this is interactive. I can pan and zoom. All this is being rendered in real time. I can, sorry, I just clicked on a detail here, dismiss that. I can pan and zoom to look at specific areas, zoom in and zoom out. This is all very interactive. I can work at the speed of thought and leverage the power of this immediate geospatial visualization to see this large data set, see all the patterns without needing to downsample or choose a specific subset of my data. Okay, so that's basic feature-based rendering. Let's turn that off for a second. I want to show you now heat map. So heat map would be probably the next thing you might try. I want to not just render those as points, but I want to see counts, see intensity, see where there might be more activity versus less activity. So that's just another option that you can turn on. Here I've configured that as an additional layer. So I'm going to enable that heat map by choosing that option here. Here I'm going to specify which specific coordinates or geometric feature I'm going to use as the basis of my heat map. So I'm choosing the longitude and latitude as part of my data set. Configuring what specific color map I want to use. We provide a variety of different color maps you can use to highlight the specific attributes you're interested in. Again, I can choose how the blur size and some other behaviors here are associated with the heat map. But let's go with this for now, and I'm going to just turn on that heat map. So here you see, again, similar implementation or similar visualization, but now I can start to see points of more intensity where there might be larger number of ships, larger number of messages being sent, again, as you would expect in areas of high traffic along the coast here of Western Europe, Northern Western Europe, the coastline of the United States, or if we start to look further west into the Asian region, you'll see high degrees of traffic coming in and out of China, for instance. Okay, so these are some basic visualizations that you can see. And again, I want to highlight the interactivity and the ability to pan and zoom easily against these large data sets. 100 millions of rows are being visualized for you in real time. But the other feature to show is the ability to cross-filter from Tableau to Kinetica. So any of the other sheets that I've dragged into this dashboard, I can now use as filters to limit the amount of geospatial data that I'm visualizing. So for instance, if I only want to see the ships that are currently moored, not those that are underway, I can just do that by clicking on this filter. That will trigger a filter to be sent to Kinetica's backend. And now I see a different heat map just showing the data points where ships are actually moored or currently anchored at in a port. Okay. Similarly, I can do that for other filters here as well. If I wanted to just zoom in on specific countries of origin or specific types of ship, let's take a look at, for instance, the fishing boats that are currently located here on the coast of the United States. We can turn that on as well. Okay, now we get a sub-filter, and you can see a lot of the fishing boats coming out here out of the Massachusetts area. All right. Let's transition now to show you a little bit another detail that we might want to see. So here I'm going to zoom in specifically to Asia. We talked about how AIS data was being used to understand shipping patterns, especially around supply chain bottlenecks that were occurring. And in this case, I just want to look into specific traffic that I'm seeing around the coast of China. You can see here the Korean Peninsula, Japan, but specifically I'm going to zoom in here around Shanghai. Again, now using just a heat map, you can see certain levels of intensity, but otherwise not really any interesting patterns that you might see as part of this demo. If I zoom in a little bit more, also not much that I can realize here other than seeing certain travel lanes and where there are potential high degrees of traffic coming into China. But now I want to introduce a new type of visualization that we support called a class break. So I'm going to turn off that heat map. And now I want to actually look at the speed. So let's take a look at the speed of these vessels and see if that tells me something interesting. So to do that, I'm going to use another style called a class break. So this, we're going to take a look at the speed, and we're going to bucketize the speed of those vessels and show different colors for their actual speed. This is all done automatically, or it has automatic options for you within the widget. I chose the specific column that represents the speed as part of those messages. And then I can generate the number of bins that I want to use to bucketize that speed data. So you can see that the speed of the ships varies from 0 knots on up past 9 knots. So this Kinetica has automatically bucketized that, or created appropriate buckets for me from 0 to 3, 3 to 6, 6 to 9, and 9 and above would be indicated by blue. I can then choose relative sizing for each of those data points that I want to show and what shape that should be used. But here I'm going to just go with these defaults, choose update, and let's go ahead and turn this one on. So now you see a much more interesting visualization where you can see the high-speed ships, or relatively high-speed ships, cargo ships and otherwise, traveling on these main thoroughfares, north to south or east to west, indicated by blue. And then as ships slow down or they start to enter port, you start to see other colors, yellows, oranges, and reds, to indicate that they're slowing down or entering port. But now I want to zoom in and look specifically at some of these red dots because I'm curious about what that might indicate. Those are off the shore, but they're not at port. So what's actually going on here? Excuse me 1 second. I think I just need to reload this. Zoom out again to re-trigger the visualization. Oh, I'm sorry, I reloaded it and turned it off. Let's turn that layer back on. This is the speed layer. Okay, back to where we started. So now I can zoom in a little bit more to see these red dots. And if I zoom in far enough, you start to see some interesting patterns where they actually look like circles. Zooming in even further, you see a whole bunch of circles. Again, alongside these major thoroughfares where the cargo ships are coming through at speed, you have a number of ships basically not traveling, sitting in one space and rotating around. If we look at these in detail, we can click on one of these and get detailed information. So now we're actually navigating, or we're able to visualize all the data associated with that point, all the columns of that specific data point. I can scroll through here, see a little bit more, see if that triggers any insights for me as I analyze this data. And one thing I'll see as I go through here is that these ships are actually anchored. Then it started to make sense that if we look at the status of these ships, seeing that they're anchored, what's probably going on, and the reason you're seeing these circles is that they're anchored. The antenna for the AIS transmission is at a certain point, and as the ship is spinning around, as the wind patterns change, it's actually generating a circle or a circular pattern as these ships are anchored. At least that's my current hypothesis to explain what we see here. Again, this is another interesting pattern that you might not see or might miss if you were to downsample the data and only work with a smaller set of the data. All right. So one last thing I want to show you in the demo is we're going to transition to a specific detail here. One of the other interesting anomalies I saw in the data looking at this AIS data is a certain strange pattern over Africa. So a lot of the data looks straightforward and normal, as you would expect, indicating ships, but suddenly have almost like a grid pattern over Africa. There are no major waterways through Africa, and also the rectangular orientation of this data indicates there's probably some issue here. Maybe this could be an issue with the data itself coming from AIS, or maybe the data set as I loaded it into Kinetica, there was something wrong with my data engineering pipeline that introduced some anomalies here. So I want to take a closer look at this data and inspect what might be going on here. Again, this might be something you miss if you had downsampled the data. Maybe you'd say, I don't really care about ship traffic on the continent of Africa. You may have missed this data if you weren't looking at the entire data set. But now what I can do is I can also use another feature in this extension to isolate these specific data points by drawing a geometry and just filtering on that geometry. So we're going to turn that on here. I'm going to turn on the option to freehand draw a geometry. And since there aren't any real valid ships in Africa, I can be pretty imprecise with this geometry I'm drawing. I'm just going to draw around that region, isolate those specific points. And now I can look at the characteristics of those points. We filtered now down to just a couple million rows around that specific viewport. And now I can look to see if I see anything interesting about those specific points. Ship type is null. Okay, that's interesting, but we saw that on other data points, valid data points as well, that a lot of ships were not setting their ship type. Country of origin, again, a lot are not set, but you also see some valid countries like China and Norway being set in the data. So that doesn't seem to tell us much. Some don't have a navigation status, some are underway. Okay, also not so interesting. But what you do see is the vast majority, in fact, looking at the real problem data here, they are all of a specific message type. They're all of this binary broadcast message. Again, that could be a flaw with the AIS data source I'm using, or it could have been something wrong in my ingest process that specifically didn't properly transform these types of messages, or perhaps corrupted those or misset the location. And that's an interesting insight that I've now found, and I can dig in and explore that further because I was able to visualize all of this data at scale and combine it with other filters and other analytics that I'm using as part of my standard Tableau dashboard. All right, that concludes our demo. Let's switch back to the presentation. Okay. All right, just to summarize, what you were seeing here was basically a server-side visualization powered by the Kinetica database, where using the power of our Kinetica distributed database to accelerate the visualization of this data, doing all that heavy lifting on the back end, and actually generating images that can then be easily rendered as part of your Tableau dashboard. This is all done using standards. So the Open Geospatial Consortium specifies this web map service protocol where the client sends a request to Kinetica. Kinetica renders those images and they can be then visualized in the client. And we showed you some of the rendering modes. We showed you raster, class break raster, the heat map. There are others that we support as well. So you can do contour maps, labels as well. And this can be then shown in a variety of different clients. We showed it in Tableau. You can build custom web applications to render these images. Or on the right-hand side is actually our own SQL workbench, where you can see this same visualization as part of a SQL analysis that you would be doing in our tool. Just real quick about Kinetica itself. Kinetica typically acts as a speed layer on top of a data lake, a data warehouse, or tiered storage inside of your existing enterprise environment. Starts with streaming data and the ability to ingest high rates of streaming data at speed into Kinetica. So today we were showing you a static data set, but again, that was all real-time visualization. Could have been data that was ingested in real time, and would also be able to do the same types of visualization that we just showed. So you ingest that data into Kinetica. There you have a variety of different analytic capabilities, 130 plus spatial functions. If you're familiar with PostGIS and the ST type of operations that you would do with spatial data inside of a PostGIS database, you can do all those and more within Kinetica as well. We also add graph capabilities so that you can do certain types of graph analysis to understand shortest path or supply-demand optimization, etc. as well as integration with a variety of different analytical applications, whether it's Tableau that we just showed you, standard SQL 92 applications, or other APIs that we support as well. Real quick, talking about some of the reference customers we have, just a sampling of the enterprise customers we have here, starting with T-Mobile. They're using some of the same capabilities we just showed you to analyze their network, their 5G network deployment, and see how it's optimized, looking at the signal strength information they have coming from their subscribers, combining that with building footprint information, the road network, to see where their network's best performing, where they might have issues. Liberty Mutual using the same capabilities to understand claims management, predict where they might have potential claims as storms are approaching a certain area where they have insured properties. They can analyze the roof material, for instance, of a commercial building they might have and predict what might be the damage as a storm of a certain intensity comes into that area. And last but not least, Ford is using the same capabilities to do connected car scenarios. What are the areas where it's safe to enable the self-driving capabilities of Ford's vehicles? What type of road segments do they want to enable that based on characteristics of the road, safety of the road, the curvature of the road, and the behavior of other vehicles in that space? So just a few reference customers that we've been working with using these same capabilities. And that's it, what I wanted to cover today. If you're interested, go ahead and try it out now. We have a free sign up for a free version of Kinetica in the cloud called our free SaaS offering in Kinetica Cloud. You can try that out with the link reference here. Go to cloud.kinetica.com to sign up today. And you can also install the extension that I showed you for Tableau. Just go to the Tableau extension gallery, search for Kinetica, or you can use the specific link here. And with that, we'll open up for questions. If you have any questions, you can go ahead and type them in to the chat box here. All right. So first question, is the Kinetica extension free or is there an educational discount program? The extension is free. Yes, so the extension is free from the gallery. You can download that straight away, and then combined with our free SaaS offering, you can actually use Kinetica for free, up to 10 gigabytes of data. You can sign up with just providing an email address, use it with that extension, and use that to do the type of analysis we showed today. Is this software using satellite data as a base data map? And the version I was showing, we weren't using satellite data, but that is an option that we have. Another option, you can just turn on a satellite base map as well if you like. Is the free link available only today? No, we're offering that free plan forever. So you can sign up now, you can sign up tomorrow. That'll be available for free. And there was one last question. Do you offer some short courses? So there are a number of educational materials we provide related to this. I know this was quick today, but there are a variety of YouTube videos, sample workbooks. If you sign up for our free offering, if you go into the product, there'll be educational materials as part of that to help you get going, tutorials to get up to speed on all things Kinetica. Good question. See, there's a question about Power BI. So today we're showing Tableau, but yeah, we support a variety of different BI tools and integration with those. Power BI can connect to Kinetica using JDBC or ODBC connectivity and then do the similar type of analytics. We haven't built out all the spatial capabilities in Power BI that we've shown here with Tableau. For a lot of it that we showed today, though, that would be possible. Superset is another tool that we integrate with Esri as well. Checking the other questions here. Yeah, if there are questions, there's some questions about performance. Today we're showing messages where we're really just visualizing points, but we also are able to visualize tracks. And there's a whole bunch of information on our website about how we perform. So if there are questions about benchmarking, check out our spatial benchmark. We showed how we perform on typical data sets against PostGS and other databases, and I think you'll be really happy to see how well we perform as data sizes get larger. All right. Other extensions offered by Kinetica for right now, we provide basic JDBC and ODBC connectivity with any BI tool. We provide Postgres compatibility. So if you have tools like Grafana and other visualization tools that talk to a Postgres backend, we can integrate with those as well. But really, Tableau is the first one we've gone a little bit further and really enhanced it to provide this more native experience and support all the visualization capabilities we showed you today. All right, I think we covered most of the questions, and I know we're coming up here on time. Any last questions? Okay, I see a question. Yeah, maybe a question just about further evolution of this product, where we see it going. There are other capabilities that we support in our backend and we support in our WMS rendering capability that we haven't yet added to the extension. So look for those coming shortly. Things like contour maps that I mentioned, some other special optimizations that you can do with the WMS endpoint. So those are things that we're looking at right now. We also have vector tile support that's coming, so that you'll be able to also, if you do want to do client-side styling of those points, you'll also be able to turn on our vector tile service and then render those points client-side as well. Question about SDK and shapefiles. Yes, so we do have an SDK for all the major development languages: Python, Node.js, JavaScript, Java. All those have a direct SDK from Kinetica for querying the database or storing data, as well as a standard REST API that we support. And is it possible to store shapefile? Yes, so we can ingest shapefiles, WKT, WKB, JSON as well. Those are all possible to directly ingest and store and work with in Kinetica. All right, any other last question? Okay, I think we got through them all. Want to thank you all again today for attending and all the great questions, and hope you get a chance to try out Kinetica in the near future. All right, take care.